Okay, we're going live? No? Okay. Hello, everyone, and welcome. I'm Meetu. I'm a software engineer here at Totus Labs in California. I'm very excited to introduce Tech Talks at Labs. This is a new forum for discussing upcoming technologies and exciting technologies. These are technologies that we have used or we want to use, or it can be something that just is interesting. We find it interesting and we would like to share with others. And for this forum, we will have speakers from our labs here and also guests from other companies. And our hope and goal for the Tech Talks is that we will spark your interest in some of these technologies and that you would find yourself using these down the road. And for more information on Tech Talks at Labs, please visit our website, www.totuslabs.com/tech-talk. And there you could find the schedule and topics for our upcoming talks. And so today we are officially kicking off this Tech Talk event. And for our first event here, we have with us Mr. Sastry Vedantam from Oracle. He will be talking about MySQL strategy for SaaS and e-commerce. And he'll be focusing on replication and clustering. So, and if you have any questions for him on this topic, you could tweet with hashtag TotusLabs, and he would get to some of these questions towards the end of his presentation. And so I would like to now welcome Mr. Sastry. Thank you.
Good morning, good afternoon, good evening, wherever you are in the world. My name is Sastry Vedantam. I'm part of the Oracle MySQL team. And today my focus is primarily on how MySQL can fit into SaaS as well as the e-commerce business. And more focusing towards the replication and cluster. So I will go some deep details in both areas, particularly in the replication as well as in the cluster. And also at the end, I would like to do a demo of one of our monitoring product called Enterprise Monitor. Let me kick off with the agenda, primarily focusing, as I mentioned, we wanted to give a little introduction to the SaaS, what kind of characteristics primarily involved in the SaaS applications. And then one of the primary things that we really want to focus here is how Oracle really treating MySQL. This is a general question they always get whenever I do any presentation on MySQL. And then focus more on in terms of how MySQL really fits into the SaaS, both MySQL as well as MySQL Cluster. So there are two products which we will be discussing today. And of course, I'll be talking more about our Enterprise Edition and also followed by a demo. With this agenda, let me show you a safe harbor statement. This is basically saying that, okay, if any of the enhancement of future releases that we have planned, and you are responsible. I'm not responsible for putting into production. All right. With that, so SaaS definitely this is an area or an area of growth in terms of platforms or how you really deploy. And this is one of the three offerings within the cloud. So if you really see SaaS, PaaS, or IaaS, so software as a service is one of the big initiative, and there are a lot of growth or initiatives happening around the SaaS. So primarily the primary focus here is to use an application or a package over a web using a browser-based access. That is the prime area. So you wanted to have very thin client access, which will give access to the end users. So that is the primary functionality of a SaaS. You see here, there are some examples which mentioned here: Salesforce or Google Apps. So these are the predominant SaaS. And throughout my presentation, I'm going to showcase some of the case studies where MySQL is really deployed in SaaS as well as e-commerce application. And the primary capabilities or critical capabilities that any SaaS application or SaaS provider should really consider. So there are things like availability of the application, or the performance and scalability of the application. So you should be able to scale enormously based on your growth requirements, and also the security of the application. So they're talking about the security of the data as well as the overall access provisioning, and also the affordability, the cost, overall cost to really deploy the solution and to run it. And of course, the integration with the peripherals as well as into the system. And another final important thing is, okay, you deployed a solution, and then the manageability, how easily you can manage. So those are the critical factors you need to consider when you're really building any SaaS application. And definitely all these factors or characteristics are applicable to the underlying database. So through the SaaS offering, the database should have all these qualities and capabilities. So those are the characteristics I will be talking in detail, particularly about the availability or the performance of how MySQL can achieve all these capabilities. If we talk about our the MySQL history a little bit, and also how Oracle is really working towards making MySQL better. So if you really see last 4 years of history in the MySQL, after the Sun acquisition, we released enormous number of products, and the innovation is happening completely on MySQL. So the current version of MySQL is 5.6, and the number of products that we worked in different areas. We're talking about high availability, we're talking about the data security, talking about the scalability and performance. We're also talking about the different utilities that needs along with the database, and also the data backups, the monitoring aspects. So in all those areas, we have products that are released in the last couple of years. If you see things like your MySQL Cluster, the 7.3, that's a latest version, which is a complete high available 5.9 solution. So and in the later slides I'll be showing up some of the architecture, how MySQL Cluster achieves 5.9's high availability, and also some of the enterprise tools which we are talking about, the backup, the security, the scalability, the monitoring, and all those aspects which we will be talking about. So if you really see the overall, the amount of innovation is happening at Oracle on the MySQL is enormous. And just a snapshot of where MySQL is really getting deployed in particularly in the cloud, and because this is one of the area where we see of usage and growth, and people are adopting to MySQL and people are deploying. So if you really see in the SaaS model, there are some examples, things like your right now clickability, or Zimra, or DocQ, or Sugar CRM, Workday. So these are all some of the examples, big customers where they deployed their different solutions, whether it's a CRM solution or a document management solution, or even any other e-commerce solution, which is deployed and running on the SaaS model. Simple, one of the use case that we're talking about is right now technologies. Right now is they use MySQL for their CRM system, so it's deployed on a SaaS. Some of the key highlights here is the amount of data that they're storing in MySQL, 30 plus terabytes of data, and 17 billion queries per month. The viewers are reviewing the data and things like that. So these are all some of the stats that a use case that was completely running on MySQL. Clickability, this is again another big example where we're talking about on-demand content management. So the SaaS is primarily talking about on-demand. Okay, so some customers wants to a requirement, and you should be able to provision that at an on-demand basis. That is the primary model of a SaaS, because it's not like you know the future requirements at the beginning and then deploy. That's the normal hosting operation. But in the SaaS model, it is basically you, as and when the customer really wants some demand or expected some potential growth for a short period of time or long period of time, then you should be able to scale out and deploy the solution. So that's a main on-demand requirement. So this is another example which I was referring here, and a content management solution which their clickability is deployed, and where the customers like Cisco, NetApp, or even CNN, they are their clickability customers who are accessing the complete content data. And here again, in terms of the data, and primarily the focus here is, okay, once you deployed, how do you manage, how easy to manage, okay, what are the tools that are required to manage that. So those are the main points here, particularly the things like the Enterprise Monitor, the auditing, the backups. Those will help to monitor your application very easily. If you're talking about 30 plus MySQL databases, which is a simple DBA skills. So that kind of manageability is always an aspect. Okay, another example, as most of the people know about Zimra. Zimra is the web hosting, and again another big MySQL in the SaaS environment. We're talking more in terms of, okay, what are the different products that, as part of the Oracle, particularly, which are good or better in the cloud environment. We have three products. We're talking about MySQL Database, and a MySQL Cluster, and an Enterprise Edition. So these are the three things, and we'll go more detailed about how the MySQL Database functions, what kind of features it has, and also more about the Cluster and Enterprise. Just wanted to show you a web reference architecture. If you really see how an organization is deploying different applications and how they are fit into each other. So you have always user login, session management. That is the first entry point into any of the organization. So that session management is the first point. And of course your e-commerce or any of the uh, business applications. So that's a middle tier. And the last tier is basically, okay, you have an entry, you have the application is running, you have a lot of data is generated, and how do you manage that data, whether it's a reporting, whether it's search engines or any of those. The whole content management comes into picture here. So all these are different modules, different functionalities, but they all can be integrated into the different architectures. If you really see here, the session management should be always performance is a criteria there, because that's an authentication process. So when you authenticate it, a user or anything, you should need to have the higher availability or faster response there. And in e-commerce, there you need to have the data integrity, data transactional capabilities. Those are the things which are required in the e-commerce area. And of course, in the content management side, it's more of report generation, managing your large volumes of data. So there are different architectures that fit into this model. Let's see another reference, which is primarily a combination of both MySQL Cluster as well as MySQL Database. So cluster is good for certain use cases, primarily high throughput or high scalable requirements. You need an instance response, millisecond response is what is requirement. In those cases, you always deploy the MySQL Cluster. So the session management, let's say an example, which is always your authentication process should be very fast. You need to have the millisecond response requirements. So in those situations, what you do is you always deploy it on a MySQL Cluster. So which is completely high available 5 nines with in-memory database. So, and then when you're talking about the next level in the e-commerce and also in the content management side, we have the complete scale out architecture. So how you can scale your application rapidly using your MySQL replication or even using MySQL Cluster. So this is just to give you an idea of how MySQL can be really used in different areas, whether you're talking about sessions or e-commerce or even the content or any other different areas, which is completely supported by the backups as well as monitoring and all the enterprise features that are required for you to monitor, talking about the data security, data backups, or auditing all those features. Let me touch base one of the first and critical aspect when you're really building a SaaS application is the high availability. So MySQL comes with a native scalability feature called replication, MySQL replication. It works on the binary logs. There's something called master and slave. The master, that's your primary database, which takes all your transactions and it generates a binary log, and that will be transmitted to the next system that's called slave. And between master and slave, there is an asynchronous process that runs, and your slave will be syncing up automatically. And then the slaves can be used for different purposes, and you can keep adding more and more slaves. So this is actually one of the very native built-in process within MySQL itself. You don't need to do anything additionally. And this replication has so many features that we added in terms of making sure that it is completely performance and scalable and robust, and also data integrity. So these are the 4 factors we primarily focused, and some of those will go in detail how it really works and what are the benefits that these features will help you. We really see the architecture of a MySQL replication. So when you're talking about a high availability as well as scalability, so this is your master. This is your primary database, which if it is an e-commerce application, that's your transactional database, accepting all your data. And then you can set up multiple MySQL instances, and then the whole replication will happen between master to different slaves. This is how you can do a scale out architecture. The 2 benefits you are getting here. One is you are scaling out, you are distributing all your writes and reads between different servers. So all writes will be happening, writes and reads both can happen on master, and all reads will be happening on the slaves. So you have an application layer which talks through a load balancer, and then you can keep adding more and more MySQL servers as and when your load is getting increased. So that way you can achieve your complete scalability. So if a simple example is the Facebook. Facebook has thousands of servers running on MySQL master slave replication. So that's a very basic architecture. And similar kind of in any example which needs more reads, then you can keep adding more and more slaves. And this replication is always you can achieve different ways, whether it's asynchronous or semi-synchronous replications. And you want to make sure that this replication is fast and integrity wise, data integrity, and also the easiest way to make sure that saves are in sync. So this is how a replication works. And then really see our architecture is, we introduce something called global transaction identifiers. What are these? So when a transaction happened on a master, the master inserts a data into its table, and then when it start writing into the bin log, then it assigns an identifier called global transaction identifier, and that identifier will be assigned and carry forwarded throughout its replication topology. The idea here is we want to make sure that wherever the transaction is flowing, it has an identifier to locate. So that way there are multiple advantages of that. One is if you wanted to do a failover, so as part of the high availability requirement, so your master goes down for some reason and you wanted to bring one of these slave as a master to continue your operations, then you should be able to identify, okay, which master is really which slave has up to date transactions with my master. So the GTID will help in identifying that whole process. So whenever you are doing a master slave replication, the GTIDs are getting populated, carry forwarded throughout its replication topology, and then you can identify that very easily. And also it helps in doing a failover. So how do I do a failover? The simple is you have HA utilities that are part of the MySQL. So these are all Python utilities that are available. Things like sometimes probably it's your hardware is failure, or a system some network issue or something. You want to do an automatic failure, or sometimes you want to do a maintenance activity. So somebody, the systems engineer says, okay, I have to replace my some memory or some hard disk failure or any of those. You want to do a controlled failover. So in both the cases, you should be able to, but your operation should be continued at the same time. So these utilities will help you to do a promote one of the slave as master. Right? So things like your MySQL failover or a REPL admin. These are the tools that are part of the MySQL server. And this how you can achieve both scalability as well as your high availability. And things like multi-threaded slaves. What does this means? So between master and slave replication, it's always generally single-threaded. But here, if you have multiple databases and you want to replicate all those, then you have a feature called multi-threaded slave. That means the slave can accept replication from different databases. So if you're running a database 1, 2, 3, then all those replication can happen in parallel. This is actually one of the good examples, particularly in the SaaS area. So SaaS or a hosting area where probably you have different applications, different databases running on in a single MySQL instance, and you have different slaves, and your replication should be up to date. So you wanted to use the parallelism. So you wanted to get the advantage of that parallelism. So you have the multi-threaded slave. So you enable that multi-threaded slave. Then what happens is each database is doing a parallel replication. You don't need to wait for the other transaction to be completed. So that is the one of the best use case. And the advantage here is you're really getting much queries per second. Your throughput is almost like your depends on how many threads you wanted. Okay, if you open a 5 threads, okay, you're getting that much percentage of increase throughput for the replication. And another thing is binary log group commit. So this is one of the thing that we realized when you have different shorter transactions you happening, and if instead of writing each transaction to the bin log, you just group it up and then write into the group into the bin log. The advantage there is you're really minimizing your lot of IO threads. So that way you're really gaining the overall performance, and then making sure that your data integrity and also your logs and everything is controlled in a fashion way. Crash safe slave. This is again there is a delay between these two. Crash safe slave. So this is something which we always when suppose one of the slave goes down for some reason, and when you wanted to bring it up, then it takes a lot of time to catch up and do the things. So, and also if it is failed, and then you want to involve a manual intervention to restart your replication. So the crash safe slave, what helps is it helps to keep all your binary log details in a table rather than a file. So what happens is, and it's an InnoDB table, so it has a auto crash recovery process involved in. So the InnoDB has an inbuilt feature called auto recovery. So when a slave goes down for some reason, and when it brought up and comes up automatically, what it does is it does checks the bin log position from the table, and then it starts a replication automatically. So you don't need to do a manual coding and or even start up your replication. So that way it really eliminates a lot of data corruption, as well as it eliminates your manual intervention. This is again another important thing, particularly. Okay, you want to make sure that what you transmitted is what was received by the other server. So data integrity, because you transmitted something, and then there will be different parts of throughout the process, whether it's bin log, it's network, or it's memory, whatever. So you want to make sure that what you transmitted is what was received. So there is a checksum algorithm which is in place, and it makes sure that throughout its path, throughout in the replication topology, it makes sure that it does the checksum evaluation all the time. And another thing is, okay, high availability as well as the provisioning. If you wanted to make sure that the system should be able to provision on demand, that's one of the primary criteria for a SaaS, is an on demand of how quickly. Okay, if I ask somebody, okay, can I have another MySQL? Quickly you should be able to provision that. So Oracle, along with the Oracle VM, we have templates, predefined templates that comes for MySQL. So if you wanted to spin off a new MySQL instance, very easily you should be able to do along with the VM template. So means it has template, it has MySQL in it, and it is, if you wanted to create a special templates for your custom configurations, you should be able to do that. And that template just quickly spin off to a new instance. This is again a big thing for in terms of the SaaS area, because that's one of the on-demand requirement. And another important aspect in the high availability is the making sure that your both master and slave is available, and how quickly you can do a failover. So something happened, and what kind of failover is this. So generally, if you talk about a high availability, we talk about 3 nines, 4 nines, 5 nines. 5 nines is the instant. The 4 nines is you have a little bit time, but 3 nines is okay, you have some manual intervention or some scripts involved. So the replication comes in the 3 nines area. Now we're talking about the 4 nines, primarily with different architectures. Whether you're talking about, if you're on a Linux environment, you have something called DRBD, the distributed block device replication of that. So it involves the Linux kernel. There is a process which it does the block level replication between your master and slave. So the master is an active, and the slave is a passive. So there is a block level process happens here, which really does whatever the transactions, whatever the changes are happening, and the master will be synced to the slave. And talking about next level, okay, these are the different high availability solutions. The next level of high availability, the topmost, it's called 5 nines truly high available. So if my system goes down, but still the user should be able to run automatically. So this is one of the example. PayPal, if you really see uh, the biggest in the e-commerce space. Uh, they have a system called global fraud detection system, and they have a millisubsecond requirements, probably uh, to identify whether a transaction, somebody used a card or something, then they should identify whether it is the right user or not. So the authentication process should be done very quickly, otherwise the transaction will go through and then finally they will lose the money in terms of, because if it is not a right user or something. So the fraud detection system is completely on a high available system with MySQL cluster. Okay, what are the features for the MySQL cluster? One of the important thing is it is an in-memory database. So this is actually inherited from a telcos world, where people wants, the application requires very fast millisubsecond requirement in terms of the response. The response time is very important. So we build the cluster with an in-memory database in it. So that means all the data will be in the memory for faster access, and at the same time it will have the storage persistence. That's the basic feature of it. At the same time, you also want to make sure that it is completely ACID protected. So that's again, you're keeping something in the memory, and then at the same time you should have the ACID compliant, because you probably doing a lot of transactions in it, and also the commerce applications or any of those. And it should be okay. It's a two things. One is your high availability in terms of your application, at the same time handling more and more data with sharding technology. So it has an inbuilt auto shard, and also you have multiple servers running, and are you utilizing all the servers to the handling this transaction? That's what we call as multi-master. The multi-master means you have multiple servers deployed, and all the servers are accepting your transactions. So that's where you are achieving your scalability of your application, more throughput. And of course you should have different features, like we're talking about SQL, NoSQL, Node.js, or C++. So different ways to access the data. So always you may not be running the SQL queries. Sometimes you wanted to run them directly, wanted to access the data using an API or an application or a C++ program or a NoSQL key value pair. So these are all different technologies that all those are embedded into it. If we're really talking about SQL, Memcache, JavaScript, or even Apache REST, C++. So those are all the different things that you're. And another, the beauty of this architecture is it runs on commodity hardware, and it's a shared nothing architecture. That means you don't need a bigger SAN or storage or anything. It runs on different commodity hardwares. So that is the main idea here. Let me show you the architecture, how cluster really looks. So the cluster it's a little different from a regular traditional client server application in terms of how your data is distributed. In a normal way, you have all the data is sitting in one location. If you're running one MySQL server or any other database server, so all the attached storage or any of the storage attached to it, and then whole data is running there, and then doing a failover or thing. But here it is completely a little bit different in terms of data distribution. So you have the different data nodes, what we call as each, these four are called data nodes. So it means all those nodes will have a part of your total data. So the whole data is distributed between different data nodes, and then you have a complete set of access layers. So your application can access this data using any of the uh, technologies, whether you're talking about accessing through SQL, or accessing through an Apache, or accessing through a C++ program, or an API, or JPA, or REST, any of those. So all those are part of your application node access layer. So this area is called the application node. and this whole area, this is called your data nodes. So that is called the cluster NDB. So there is a storage engine specifically used in this case called NDB storage engine, and that NDB storage engine uses and the data is distributed between different data nodes, and also at the same time you want to make sure that you have a high availability. Even if one of my node goes down, I want to make sure that all the data is accessible. So I will have minimum 2 replicas. That means you have 2 copies of a data. That means, so, and distributed between 2 nodes within a node group. So if, let's say, your example, an F1 is a record. Okay, F1 is a record, and a node 1, I have the F1 record, and also at the same time I want to make sure that there is a passive record sitting in other location. So that's in the node 2. So there is a synchronous replication built-in process happens automatically when an application inserts a record F1, and there is another process which is automatically does a synchronous replication into the other node. So the idea here is, even if my node 1 goes down, I still have access. So there is no impact to your application. Application will be running as it is because my passive record is available. So then node 1 goes down, then automatically my node 2 will become servicing all the data corresponding to that node group. And at the same time, and also make sure that all the data is distributed between different nodes. So that means you have a data sharding is happening automatically, and also distributed of your data. And another main feature here is how you distributed the data is for the scalability. So tomorrow you realize that you wanted to have another let's say 100,000 transactions are expecting, and then your system should be able to scale easily. So you just add another node, and what happens is all your new data can be sent to the new node, or else you can redistribute all your nodes data. That way what you're doing is 2 advantages. One is you're distributing your data, as well as the memory, the in-memory of all these nodes will be used. So that means your node data, all the data is primarily in the in-memory database, and then that way your response time is much quicker than reading from a disk all the time. So that's the main architectural principle, and it's completely supported by a management tool, because we have different components involved in it. Make sure that it runs smoothly, and then even for scalability wise, even for upgrades, backups. So for all those things, you have a cluster manager. Primarily API access, as I mentioned earlier, the data nodes are the underlying areas, and that's basically it stores just the data in an NDB storage engine format. But how the users or the application can access using the different layers. And one of the thing here is the memcache layer. So some of the things which you want to do a key value pair, just a starting point for a NoSQL access. So you define your key and a value. So, and then you probably want to do bulk loads or bulk retrieval of the data using just key value pair. You don't have a SQL complex requirements are not there. So in that case, you can directly access through a memcache. Or if you wanted to build some complex queries on the same data set, you should be able to run through SQL using your supports your JDBC, PHP, or Python, Ruby, or any of those application languages. So that's the main the architectural advantage here. And mix and match. Basically, you are getting the best of the both worlds, whether talking about SQL and NoSQL. So on the same data set, you can run a SQL query, and at the same time you can do a NoSQL query also. This is one of the benchmark. We'll see 1.2 billion updates per minute. So that's how you can scale your cluster. The response time, how fast you can get for a workloads, and at the same time you want to make sure that it is completely ACID transactions. You want to have high availability all the time. And next aspect is your data protection. Okay. There are some examples that I just wanted to show you in terms of e-commerce area, because that's where their data production or data available security is very aspect. So Ticketmaster.com, this is again the example where they use MySQL for all the events that are happening on the Ticketmaster.com. And if you really see some of the workloads, that amazing workloads. So they handle the sales tickets for 120,000 events at 24,000 venues. So this is a big activity, and throughout the everything is running on MySQL. That's the differentiation here. Of course, the eBay uses MySQL for scale out architecture. They use the MySQL completely. And some of the metrics you really see, that manages 4 billion requests per day. And there the beauty is they have 50-50 reads and writes. So they have a master and they have a bunch of slaves, the scale outs. And how your data is completely transactional. That's an important aspect, because for any e-commerce application, so that's a primary requirement. And we in MySQL we use a storage engine called InnoDB. So InnoDB is storage engine. It gives you the complete asset compliance. It's a transactional throughput, as well as you wanted to make sure that data is completely consistent, data intact. So it's a fully asset, and the way it works is it has multi-versioning, it has data consistency, and as well as its performance wise. So we can achieve all those things. And some of the features that we introduced in the latest version 5.6, talking about things like primarily deploying on an SSD. So the latest these days, if you see any hardware, SSDs are becoming more and more popular, because the faster access. So at least for the set of data that you really wanted to deploy, or you wanted to access much faster, so those can be deployed in SSDs, if not all. So we have done a lot of optimizations specifically for deploying a MySQL table data on an SSDs. And some of the things like your for DBAs, particularly, okay, doing things online DDL operations, you should be able to create your indexes or rename columns, or indexes, any of those operations you should be able to do online. So that's a very key important aspect. And of course, when you really having a system running, and then you wanted to reboot your system for some reason, or the application, okay, the time it takes to load or to bring to the normal state is an important aspect, because your downtime is always limited, and then after your restart, okay, bringing back to the normal state is a big aspect. So we introduced something called dump, restore, and buffer pool. So the buffer pool that you built over a period of time, all your memory, that are important things that you built in the memory, in the InnoDB buffer pool, you should be able to bring back to that state very quickly. So you have that in the future. So I'll be going some of those details in some of those little more detailed too. And of course, no SQL access, as I mentioned previously, that's again a big thing nowadays. People want to do a key value pair for faster data access, and InnoDB has that plugin right now. Things like, particularly on the web space, and also even for other some of those read-only use cases. So we optimized InnoDB. InnoDB, even though it's a transactional, we want to eliminate the overhead requirements for read-only operations. If you're doing a select, you don't need a transactional lock. So because it's a select, you're not really doing any transaction there. So whenever you run such kind of queries, now InnoDB is completely optimized, and there is the lock. It eliminates the lock and just treats it as a read-only operation. That can be done set automatically as a default, or else the programmer has a control to do that also. Thing is the DDL operations. So the features that we are talking about, primarily most of the time, as part of the maintenance, a DBA will say, okay, I have to create some indexes, but I have to shut down the machine, so that I need a downtime. So those are the criteria. So now with the MySQL 5.6, you don't need to worry about that. Then I would ask for a downtime and things like that. on fly, you should be able to manage that. You should be able to create indexes. And of course, other things like your reorder columns or drop, or changing up factors like your column and other things. This is one of the thing, primarily make sure that your it gives you flexibility to add flexible schemas, and at the same time you should know downtime requirements. So this is one of the actually features that really a lot of people initially started considering NoSQL options, and then with this feature they'll still continue to be as a part of a SQL, because they can build any complex queries. At the same time, they can also do a lot of alterations and management very easily. This is a dump and restore buffer pool. Primarily, it shortens your uptime from hours to minutes. This is a big example in the cloud area, cloud space, and hosted as well as SaaS model, because when you're starting an application, you wanted all the users should be able to access to their previous state very quickly. So the restore will have that. So there's a hot the snapshot is taken before the shutdown, and then when you brought up the system, it automatically comes back to the normal state with that. Full text search. This is again a big thing. In the traditionally in the MySQL MyISAM storage engine has a feature called full text search index. Now with InnoDB, you want to run the similar kind of thing. So now in 5.6 we have the full text search, where you should be able to create the full text indexes, and you can run queries like your search queries based on some strings on the same transactional data. And transportable table spaces. This is again a big thing in terms of you wanted to move some of the data to another high available disks like SSDs, as I mentioned. So probably those data like your authentication data or some particular tables validation data, you wanted to keep it on a high available disks for a faster access, and transportable table space will help in doing that. So it's very easy to move a partial data, or even you wanted to move some data from one database to another database, so particularly in the SaaS model or the cloud. So we have another database instance, we want to move some of the data to that, so then the transportable table space will help in that. And of course, NoSQL access, as I mentioned. Initially we started this in the cluster, and now we extended that feature into the InnoDB also. That means you have the InnoDB storage engine, and you are accessing through your memcache, as well as you are accessing through the SQL. So that means you have best of the both ways. Directly you can access through a key value pair. At the same time, you can also access through your SQL operations. And the advantage here is, if you want to write a key value pair, and for fast data loads, it gives you 9 times performance than a SQL, because always you're within your in the SQL area, you have a different components involved, your parser, your optimizer. So your query should go through all those things. Now with this, directly you can talk to the database using a just simple API. And also another thing that we've added in as part of the MySQL is a lot of instrumentation. Okay, we have transaction capabilities, we have high availabilities, but for somebody to monitor or manage the system, you need some data instrumentations. So we have added a lot of features in instrumentation, particularly in different aspects. Okay, whether usage wise or tables wise or data wise. The idea here is, okay, for you've deployed a solution, and then you want to understand how that your query pattern is happening and what kind of queries you are running, and a lot of measuring aspects of it. Let's see here, particularly in the hosted area, say that, okay, what application users, who is accessing more, what kind of complexity queries they are running. Those are all things that can be measured with the performance schema. Right? This is a schema that is inbuilt, and it gets an instance access, and then you can say things like your, okay, this particular customer is running so many queries. Okay, this particular user is running this kind of workload. So it's a common deployment, but you can measure, or for you to charge back or any of those, you can build a process. Okay, these they are running more complex. They're using more usage of the InnoDB buffer pool or the memory or any of those. So for you to really plan out your chargeback, this will help you in that. And scalability. You really see our benchmarks. This is benchmarks compared to the older versions. Really making sure that your transactions per second is achieved. At the same time, scaling on a bigger hardware. So as you know, nowadays, initially when you started in way back, maybe 8 cores is max, the MySQL process. Now you can go up to 60 cores. That means you have a bigger box. You want to make sure that you utilize all the hardware power for the process. So now with the 5.6, now you can do, you increase your TPS, as well as you are also making sure that your horizontal scalability is happening vertically as well as horizontally. We move on to the enterprise edition. So what are the things that Oracle really brings onto the table here is, okay, database server, you have so many functionalities that we built in, and once you deploy a solution in a production, the main requirement is how do you manage that, how do you make sure that that enterprise level monitoring or the support activities are there. So if you really see here, all the features that we are talking about here, right from a monitoring to a data security to a scalability to a backup. So those are the areas that we believe part of the enterprise. Enterprise monitor. So let me skip this slide and I will show you the actual live demo of this, how it really helps you to monitor the details of the MySQL server. So how MySQL server is behaving, the health, everything. It has so many advisors, 200 plus advisors, works on different areas. How is my queries are behaving, how is my security device is behaving, how is my backups are running, and things like that. And enterprise backup, it's an important aspect. Okay, you build a solution and deploy it, and taking a data security, data backup is always a big thing. Okay, because you need to have a data backup, otherwise you'll the recovery, the instance, the always a big activity. So enterprise backup is a true online backup. That means your application can run as it is on with InnoDB, and then in the backend, in the background process, you can should be able to take the backup very quickly. At the same time, you should be able to take a full incremental or a partial backup for you to really plan your backup strategy. It supports compression, and another important thing is point in time recovery. Okay, you have taken a backup, but if you are not able to recover that to the point, then the backup doesn't make sense. So the point in time recovery is an important feature, and of course it works on different platforms as well as database size. Another important thing is the scalability. Okay, this is one of the big thing in the SaaS area, where as your number of users are getting increased, how your application performance is really sustained. If you really see in the normal behavior, what happens is the external connection to the internal execution is always a single threaded process. But here with the enterprise scalability feature, it's called thread pooling. So what we do is the internal execution is always created as pools. So we created different thread pools, and then we make sure that the parallel execution is happening. So from external connections. So suppose you have today you have 128 concurrent users, and tomorrow all of a sudden there is a high demand. Okay, for at the month starting or month end, depending on different business scenarios, and there will be more users are logging into the system. That your concurrency increased, and at the same time the customer should not feel that okay, system is running slow. So that maintaining at the same speed or same performance is always a requirement. If you really see here, at a 128 concurrent users, you always after that when the concurrent connections are getting increased, you always tend to see that drop down. This thread pool will help you to maintain that 10,000 or 12,000, whatever the TPS you are achieving previous and also tomorrow, the same making sure that the thread pool will create different pools, and then your execution will happen in parallel. Another important aspect is security, the data security, okay, or user security. So different users, probably you have DBAs, your application users, different users who are logging into the system, and if you wanted to authenticate all those users through a global authentication model, probably like an LDAP or an Active Directory, or depending on the configuration, you should be able to integrate that with that MySQL. That means you don't need to maintain a separate password within MySQL. So once you have an LDAP user, then you can just link the MySQL access to that. So you can create a role there, and then automatically through a pluggable authentication model, it goes and authenticate when you try to log into the system. Another important thing is audit, okay, data auditing. So there are so many people that has access to its system, and who is doing what. Okay, probably DBAs are doing some monitoring the system. Same time, you want to make sure that who is doing what. That kind of auditing requirements, particularly from the compliance requirement, probably, or even for internal analysis purpose, the enterprise audit will help you to do that. That means just simply enable the plugin, then that time onwards, who logs in, what time, what he has done, it gives you the complete details. So you can build a complete search spunk on it. Let's see the summary. For the SaaS market, okay, it's definitely it's a growing market, and another thing is it's one of the primary thing within the cloud. Want to make sure that your solution should be low cost, easy to use, scalability, HA, reliability, and security. So those are the main aspects. In the beginning, you have touched high availability, scalability, and things. So those are the areas which really MySQL fits in, and then gives you the best of the solution. With that, I will pause here, and let me go to the demo of an enterprise monitor. All right. So this is a demo of an enterprise monitor. The, once again, let me make sure I have my things connected. The main idea here is you have deployed so many MySQL instances you are running, and you wanted to make sure that there is a unified tool that really manages, monitor all your database instance. So right from the status, whether it's running or not, what kind of activities it is doing, are there any critical issues that you need to address, or what kind of queries that it is running. So you really see here this is a snapshot. In the morning when you come here, you want to make sure that everything is green, then you are happy. If there is something red, then you really need to start thinking, okay, what are the issues? Okay, are there any critical events or emergency events? And accordingly, you can build a notification system through your email system, so that the right people will be notified and act accordingly. And for each of the event, there is a complete details process, or an activity involved. Say like if you have let's say this is an example. What is the problem? What kind of advice the system can give to solve that such problem, and also for further reading. So it gives you the complete snapshot or complete details how to solve an event also. And also it gives you things like your uh, my general access pattern on the connections or on the database activities. How many connections generally I see on my system, or what kind of activities am I observing, more selects or more instance. Accordingly, you can plan your scalability also. And if you are doing a replication, then you can monitor your complete replication topology. You have a master, multiple slaves, and how is my replication is happening, and is it are there any, is there any time behind, or is there any error, is there any failure? All those things can be captured here. So at this moment, I have so many uh, events that are happening on different servers. So things like your some SQL statements, general warnings, or else my slave has stopped replicating, or my agent CPU has excess memory usage, or even anything has restarted, some process has restarted. So it starts giving you complete events. So each event can be addressed with more detailed activity, how to solve that problem. So this area, it gives you an advice to solve your, so you solve an issue. This is a kind of virtual DBA for you. And also I can get a snapshot of the queries that are running at a particular time. You really see here, in this particular time, I have, these are the different queries that are running by different users, and the important metrics here is, okay, this is a query that is executing for so much time, and it needs it is doing a 28 table scans. It also doing some the latency it's taking, and it gives you the complete more details, the explain plan, the way you uh, the details about the query, what kind of query it is, and also relates back to the graphs. So let me show you what kind of graphs I can get out of this tool. You can see an aggregation, or at each server level I have 150 plus graphs on different areas. We're talking about the CPU, we're talking about the InnoDB, we're talking about the security, we're talking about the backup, or different connections, or even the replication. So there are different graphs. Each graph will give you the details about what kind of activities or what kind of pattern you see in each of those. And then if I see, let's say an example of a connections here, I see some spikes, and then if I wanted to see what kind of activities are happening during that window, then what I can do is I can drill down and go back to my query analyzer tab and see these are the queries that are getting executed in that particular 10-minute or 5-minute window span. And then I can analyze those queries and see if there are anything. If you see any of the QRTI is showing as red or any other color other than green, then you go back to that query and then analyze those. And then of course you can get a complete details about a particular server's InnoDB buffer pool. So how is my InnoDB buffer is completely organized within the system, and it will give you the complete snapshot of that. So what are the different system tables I'm talking about? How is my indexes are planned? How is uh, my buffer pool is getting filled? And if I expecting some future load, okay, is that my InnoDB buffer pool is sufficient or not? Or do I need to make any alterations to that? So those kind of advices it gives you. And of course, your complete event handling through your notification system. You can create different groups based on your customers or based on application functionality, and then accordingly you can create different notification groups, and then set events. If there are a very emergency events, you can send it right away, and then you can set critical events to one of the group who needs to address. Or if you wanted to integrate with any of the things like any SNMP traps through your Nagios or any other alert management system, then you can do that also. You can create different groups of users like DBAs, read only, or managers. So you can do a complete access control pattern. And you can and the thing is, on the cloud you should be able to add more instances very quickly. So on a mission, if there more MySQL instances are added, then automatically the monitor will detect that and tell you, okay, I have some more instances that are waiting for you to monitor. So some instances are bad connection, so it gives you all those notifications for you. And these are all, the monitor completely runs on a concept called advisors. So what are the advisors? These are the predefined rules that are built into the system, and for each of those rules they define a threshold, and there is an expression involved in it. And then for each of those, let's say in availability, I have different advisors that are running all the time. And if there is a deviation from the threshold to the actual behavior, then an event will be triggered, if it is a critical event or a warning event, or based on the thresholds. And you can define those, and you can build your own custom advisors too, and you can build your custom graphs and monitor accordingly. Right, that's all my side, and I'm happy to take questions. Thank you.
So did I understand you, at first you were talking about a master-slave topology?
Yes.
And that the writes were funneled to one and only one node, and
That,
they were replicated from slaves.
That's correct.
You wrote to one, but you read from many.
That's correct.
Okay, so there's a potential bottleneck on the right there.
There are two architectures to that. There is a semi-synchronous and asynchronous process. Okay, you can do a semi-synchronous replication happening there, and then in 5.6 the replication is making sure that the latency between master and slave is very minimized by different optimizations. So your whatever data you changed, you want to make sure that the data is transferred very quickly, and at the same time data integrity is maintained. So yes, it's not a real time. It's a second difference between master and slave. So all the reads based on your use cases. If it is a real time read, then always you can do it from the master too. So master is for both reads and writes, and for all the slaves or for reads.
But if you had a highly intensive write application, then you introduce the cluster topology, and there you can write across all nodes.
Absolutely.
And they all replicate.
They all replicated. See, if you have more write intensive, and then at the same time you wanted to have more time response requirements, so in those cases you use a MySQL cluster. So you have, it's called multi-master. So all the nodes are taking writes and reads both.
But if it were mostly read and few writes, then you'd probably take the master slave and only go to
absolutely.
cluster if you really needed that write.
That's correct.
And then there was one more on that. So a lot of new features like both being able to do selects and key value extraction. You notice the ORM layers like JPA, can you, or Hibernate, can you then, do they extend that through? So if you wanted to get some data, can you turn a switch on at the ORM level that tells it which app?
No, the JPA access is a straight away.
That'll go always
All the way. So if you wanted to, yeah, that's the reason why you have both the access layers are available. If you have to run a complex SQL, then you have to come through the MySQLD process.
Right, but I was wondering if you just had to select the user table or something, and we know how to take it to the JPA.
Yeah, you always you can do the you can.
If you had that, if you want to do the equivalent of the same select, but through key value, but still you want to keep the abstraction layer of your ORM. I'm just wondering, do the ORM tools allow you to go down to that key value lookup?
Yeah, as long as if you're able to say decide that what access pattern, what kind of access pattern you want to do access at the top, then you can do it. There's no issue in that. Right?
There is a question from a user on Twitter. Let me see here who the user is. He was surprised with so many news from MySQL. He would like to know more about the strategy of Oracle for MySQL.
Okay.
If you could elaborate on that.
Our strategy is very clear. MySQL is definitely one of the big stack within the Oracle portfolio. So and Oracle is really very much focused with the MySQL, because the use cases you really see in terms of the cloud, in terms of the web, session management, content management, those are the different use cases that are always good on MySQL. So Oracle is good for big ERPs and things, but the rest of the things like your web or your content management and all those things, so MySQL is a good fit. So Oracle is really focused, and all the innovation is definitely happening on the MySQL from the roadmap perspective. And now I talked about 5.6, now 5.7. That's with a more 500 million queries per second. That's a new benchmarks that we just released, and a lot of innovation things are happening on 5.7, and there are 2 milestone releases are already done. So we are working towards aggressively on that. Any other questions? Yes, Rash.
So I have a very straightforward question. MySQL was a Couchbase.
Okay.
So you made the difference.
I don't have much experience on the Couchbase in terms of if you have a specific functionality, then I can definitely talk whether how MySQL really fits into. Yeah. Uh-huh.
So I know MySQL can achieve all this based on everything that you put up there.
Yeah. So you're talking about scalability in terms of the load, in terms of data volumes. I have deployments with petabytes of data running on MySQL. Okay.
So,
From the data perspective. Okay. From the user's perspective, you can if you use MySQL cluster, you can scale horizontally with different data nodes, and if you really see the whole telcos, okay, whether you're talking about AT&T or Verizon, all these AT&T, the service providers, the call routing is one of the critical application for when you make a call, and first it connects to the tower and then goes to the. So from when you connected to the till you finish your call, that's an important piece for them, because that's your whole charge. Almost all providers, the solution is deployed on MySQL cluster. That's how the whole cluster is inherited. This the Ericsson has built that, the in-memory database, and then MySQL AB bought that, and then now it enhanced part of the MySQL portfolio. Now, so if you really see from your millisecond response, at the same time the number of users connected to the system and the scalability wise, that's absolutely. Yeah.
Mention about HLRs, home location registers.
Yeah.
Why it's
that's what I was just mentioning. Yeah. So the HLR system, that's what the actual name, and it's very critical application for all the mobile providers, because that's the main piece which really measures your high available system, and it requires complete high available at the same time nanosecond response. So
you're talking Ericsson, Nokia, Motorola, Alcatel-Lucent, all of their HLRs are deployed with MySQL Cluster, and they've been that way for. We bought Elzotto, which is the division of Ericsson, over 10 years ago, and so I would say it's probably been about 6 or 7 years that we've deployed all of this HLR. So as far as a mission critical system, there is nothing more than.
Yeah.
So I know Oracle traditionally had servers before they purchased Sun Microsoft. So is MySQL integrated into those existing databases, like before the Oracle purchase?
Need more clarification. I'm trying to understand. We talk about hardware, or we talk about.
No, I'm just talking about the MySQL. Today it seems to be the focus. Oracle seems to be pushing MySQL
time, right? So there was traditionally Oracle database server that existed before MySQL. You know, so is the both integrated now?
No, they're not integrated,
Okay.
they're separate products. I'm trying to just drive at your question. They're separate products. And as Shastri had mentioned, when you're thinking of, when you're thinking of, Oracle, you're thinking of, big ERP, you're thinking of, large deployments in that fashion, large applications. When you're thinking of, and again, they have the cloud, there's some, where it mirrors. But if you're starting to think of web applications, most of your web applications today, they're built on MySQL. I mean, it just has been. And so when, Larry had always wanted to have some aspect of MySQL. So before the acquisition, this is 4 years ago, or actually 6 years ago, when Sun acquired MySQL, there was actually, ended up being a bidding war on between Sun and actually Oracle for MySQL. 2 years later, he wanted to buy Sun, and the bonus was he was getting MySQL also from there. And when you look at things, when you look at the marketplace and you look at what's taking place, I mean, Oracle has 380,000 customers. Okay, so it's a massive, massive organization. We have lots and lots of technologies. But at the same point in time, when you look at MySQL, we have 10 million active installations. 10 million. There's no database company, there's no database out there that has as many usage as it. And again, he had talked about some of the stuff there. He went through it, but you're thinking of, Facebook, YouTube, eBay, PayPal. I mean, Ticketmaster. I mean, it's just, it just goes the gambit there. So that's how it's, his use has been. And you couldn't have had some of these companies, Twitter, you couldn't have had these companies come up if it was for the fact that they actually had to go out and purchase a database before they started the company. So that's where the difference is. Now, when Larry looks at us from a strategic standpoint, he definitely looks at us as a Microsoft killer category, because from the SQL Server side and from that. And so big Oracle, he's looking at from the from the higher side, and we can compete on the Microsoft side. But as you can see, we compete on cloud, we compete on 5 nines availability. So there is a lot here. Does that help?
Yeah. And also I think is also already certified with other Oracle products, as I mentioned. So like you're talking about, if you're using an Oracle middleware or any of those products, MySQL is completely certified. So and things like your enterprise Linux, the OVN templates, so it's all completely integrated into that system. And the recent use cases I can talk on the cluster is in the gaming industry. I'm sure he can talk more from the Latin and Brazil point of view, but Zynga completely on MySQL cluster. So they have 48 data nodes. They were planning to expand that. So the whole gaming industry, they wanted again a fast response, because and the failure is 0. So those are the requirements there. So it's in the gaming industry now, cluster is becoming one of the deployment architectures. Sure.
So I can see that MySQL now become another like Oracle product now, because and also OCP with 10G and also AI. So I see all these management and also those tables, whatever, it's very similar to whatever Oracle product is. So besides that, I look at the cluster architecture right now.
Mm-hmm.
How you compare your cluster architecture to the Cassandra's architecture? It seems that very similar to the Cassandra's architecture. Because like everyone is like master, they can easily add a node into it. And I wonder if the internal communication also the classic protocol as well. So do you have more insight about your cluster design for these MySQL cluster architecture?
Yeah.
You good with this? Or?
Yeah.
Because it's actually like most of the products out there basically took this architecture. Go ahead.
This is the architecture which we started a while back. So as Mark mentioned, so Ericsson has built this whole basic architecture. So like this, sharding, auto sharding, and in-memory distributed architecture. That is the basic principle how we started this, and that's how actually I really see the whole maybe 8 years, 7 years back, the cluster has started that concept. Okay, and then with now with the regular databases, other products are evolving in the similar concept. But here the main thing here is it's the 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 the, the main concept here is it should be deployable on a commodity hardware, shared nothing. Those are the principles that MySQL cluster is completely. Okay, and internally it does a lot of communication between these data nodes, and also you want to make sure that you have a redundant copies of data with the replication, internal replication is happening. Another feature here is this is completely scalable up to the geographically. Okay, you have one cluster running here. PayPal is a big example. You have one cluster running in US, they have another cluster running in Europe, and both the clusters are active all the time. So depending on time zone, your workload, you could distribute between these, and there's replication happening between, and that's not only for the scalability and also for a disaster recovery. So those are all the principles on which the MySQL cluster is built, and of course the other products like you mentioned, this or with similar thing where you doing the scalability wise, but here the faster response is the primary thing here for a MySQL unique feature.
And the company using container also very fast stuff. And you can see for the internet, 30% of the traffic like coming from the company that coming using the container software, right? So you can see Cathedral does have very good as a cluster architecture as well. So my question pretty much is not like who learning from who or whatever, copy whatever people's idea. And my idea is that to see figure out the architecture you are using in the background, is it really using the computer science basic protocol communicate between the node communications, or how they are when they're doing the sharding between the nodes, and when a new node add into it, how it we compute the sharding in the new node and how they distribute the data close in the new node. And compare your architecture to the cathedral one.
When you add a new node with MySQL cluster, the two ways you can do that. One is whether you want to redistribute the data or you wanted to add all the new data which you expected to be in that. So there are different architectures you get the way you add a node to that. So when you add a new node and you want to redistribute, what happens is the background, the redistribution will happen. Once that is ready, then it will become an online. So and there is a lot of background process internally. The NDB API handles all such coordinations within, and there are a lot of communication happening between, because there's a heartbeat mechanism needs to be involved. Make sure that each node talks to the all other nodes and for a live process, and there is a management which really talks to all these. Make sure that if there is a failure anywhere, then okay, you'll be down. The management node will take such decisions because you're not able to reach to the other things. So there is a lot of heartbeat process which are running within that.
Yes, but usually people won't do adding to the new node. I mean the new record, because that would be similar to in Oracle, right? You add a new data table space, and now all your new records go to a table space. Now you see that table space is very contented because everyone's hitting that because everyone tries to get the most recent record, right? So usually you want to distribute
absolutely. So for in the cluster, what it is, we do a primary key based or hash algorithm on which all the data will be distributed. So the redistribution will happen within the process when you're adding new node to that. Okay. Closing talk.
So thank you, Mr. Sastry, for taking the time to share all the information. It was really informative, and I think everybody here and whoever has logged in remotely will benefit from all this information and gives a new look to the whole MySQL enterprise. Thank you everyone here and for joining for our first Tech Talk. And please stay tuned and visit our website. Again, it's totuslabs/tech-talk for the schedule, where you can see all the schedules and the topics that we have. And for sure, we have some more exciting technologies that we'll be talking and discussing. So stay tuned, and thank you.